Welcome to this Community Viz video tutorial. This video tutorial is on the formula editor. It's part 3 of 3 parts. In part 1 we introduced the basics of setting up formulas using the formula editor, and in part 2 we covered indicator formulas. This part is about attribute formulas with an emphasis on spatial analysis. Creating a new dynamic attribute is similar to creating a new indicator, but slightly different. I go to the 360 Setup tab, I click Dynamic Attributes, and again I have a list of all the attributes in my analysis. To create a new one, I go to New Attribute, and I can give it a name. I can give it a description if I want to. I can assign a category, and in this case I have to tell it what layer my attribute is going to be in. So it happens that I'm already in the buildings layer, which is correct, but I could choose a different one. I also need to tell it what type of attribute. Number attributes return numeric values, and that's most typical, but you can also return booleans, which are true false, or text, and there are actually quite a few capabilities for processing text. On the Formula tab, again I have the choice of Formula Wizard or Formula Editor, and I'm going to choose the Formula Editor for this demo. Now again, I can do simple arithmetic on attributes. I can use the Insert Analysis component to insert an attribute. I have to choose what layer it's in, and then find it in the list. And then I can do something like add it to another attribute. And I have a simple formula. Again, I check my formula. In this case, when I preview, I see about 10 records, just the first 10 records. This is not actually processed, it's just a sneak preview. But it gives me some idea if I'm on track, and I'm seeing values about 2, that seems right. Once I finish this and click OK, 2 things happen. One is a new field gets created in the buildings layer, and the second is it gets populated with values. Now I had my attribute table open already, so I can see the new field has been created, but it appears to have null values. That's because I need to refresh my cache in the table so I can see them. Well, here they are. These are simple numbers. In each row, this value equals this value plus this value. In other words, I've added up the attribute distance to school and the attribute distance to landmark for each feature and given myself a new attribute called example. Now, what makes all 3 of these attributes special is that they're dynamic, which means that I can edit the map and they will recalculate their values. So for example, if I were to put in a new landmark that I had decided exists right here, my entire analysis will update. The distance to landmark values will drop, and so will the results in my example. So how did I get the formula for that distance to landmark attribute? Well, here it is. It's the formula for distance to landmark in the layer buildings, and it's a function. This is a very popular one called min distance, and its argument is very simple. You just tell it a layer to point to, and here's the notation for layers. Also, this function uses a conversion. There are a number of conversion factors built in for convenience, and you can add them by putting a multiply sign and then using this button. Now, min distance is only one of dozens and dozens of available functions. You can see them here if you scroll through the list. There's also a function library in the help, and I'd like to highlight just a few to give you a little bit more of the idea of how these things work. So here I have a graphic. The blue is the current feature that the formula is working on in what's called the host layer. So this is where I've written my attribute formula, and the formula works through one feature at a time and does its calculation. So here's the one it's working on right now. And over here is the target layer. It could be any layer in the analysis. Something like min distance measures the distance from the current shape to the nearest feature in the target layer. Angle 2 is a similar kind of function, gives you more of the idea of spatial calculations. It measures the angle of that line compared to north, so you can tell whether a feature is north or east or south, etc. Another very popular function is get from closest. What this does is look up the name or number or other attribute value of features in the target layer, specifically the nearest feature in the target layer. So for example, if these were schools and that one's named Lincoln, get from closest would tell the host layer current shape that its nearest schools is named Lincoln. And here's another one, proximity sum. What it does is add up the values, say the number of students, in all of the features in the target layer that are within a certain distance. Here's how that proximity sum looks when I insert it into a formula. Again, proximity sum, and here's the function, the familiar attribute that I can click to provide. And I just wanted to show this additional format. There's a number, 1,000, with a comment. You can tell it's a comment because there's a single quote and it's in green. And it's telling me this is the maximum distance. So the default turns out to be 1,000, but I could set that to some other value if I wanted to. I could adjust my where clause to say I only want to look at certain kinds of schools, say, and I'd be finished with my formula. So those spatial examples I gave are just some. If you look through this group, you can see there's many other kinds of attribute formulas as well. Many of them work for indicator formulas as well. And the bottom line is there's a very powerful set of capabilities here in the formula editor, which is part of Scenario 360 and Community Viz. Thank you for watching this Community Viz video tutorial. For more video tutorials and Community Viz resources, please visit the website.